All right, listeners, ready for some serious brain food? We're diving into understanding nature's laws this time. And let me tell you, this handbook is packed with mind-blowing concepts.
It really is.
It's like a crash course in how the whole universe operates.
What I find fascinating is how the book takes this holistic approach. You know, it connects physics, chemistry, biology, like showing how these fundamental laws are governing everything.
Yeah.
From the tiniest atom to the largest galaxy.
Exactly. And for this deep dive, we're zeroing in on Chapter 7, Fundamental Physical Laws Governing Nature.
Oh, a good one.
Buckle up, because we're about to explore the rules that literally hold our world together.
Yeah, you know, we often just take these laws for granted, but they really do underpin every aspect of our existence. I mean, everything from how we move to the energy that powers our lives, it all comes down to these fundamental principles.
Okay, so let's start with something I always find super intriguing, those conservation laws. The book talks about the law of conservation of energy and the law of conservation of mass.
Yeah, these are really cornerstones of physics. The law of conservation of energy states that energy can neither be created nor destroyed, only transformed from one form to another.
Okay.
So think about like a swinging pendulum.
Okay.
It's constantly exchanging potential energy at its highest point for kinetic energy at its lowest point, but that total energy always remains constant.
So it's like a cosmic accountant,
Yeah.
always keeping things balanced.
Yeah.
What about the law of conservation of mass?
Similar idea. The law of conservation of mass states that in a closed system, the total mass remains constant over time.
Okay.
Even if it undergoes like physical or chemical changes.
Yep.
Like when wood burns, it seems to disappear, right?
Right.
But the mass isn't truly lost. It's transformed into ash, smoke, and gases.
Wow, so even when things seem to vanish, the universe is keeping tabs. It makes me think about like those recycling symbols. Are we essentially mimicking those conservation laws when we recycle?
Absolutely. By reusing and repurposing materials, we're acknowledging that matter doesn't just disappear, you know?
Right.
We're participating in this grand cosmic dance of transformation.
I like that. That's a pretty cool way to look at it. Okay, so we've got these fundamental laws governing energy and matter. Where do things like heat and disorder fit into this picture? I know the book dives into thermodynamics.
Yeah, thermodynamics is all about how energy is transferred and transformed in systems. The first law of thermodynamics is essentially a restatement of the conservation of energy, but focusing on how heat transfer is a form of energy exchange.
So, for example, when I heat up my coffee in the morning, I'm essentially transferring energy from the stove to the coffee.
Precisely. And that leads us to the second law of thermodynamics, which introduces this concept of entropy. This law states that the total entropy of a closed system can only increase over time.
Okay, entropy, help me wrap my head around that. It sounds complicated.
Think of it as like a measure of disorder or randomness.
Okay.
Imagine a neat, organized room. Over time, without any effort, it naturally tends towards messiness. You know? Clothes on the floor, books scattered about. That's entropy in action.
So the universe is constantly becoming more chaotic. Is that a bad thing?
It's not necessarily good or bad. It's just a fundamental tendency. You know, the universe is constantly moving towards a state of greater disorder.
Okay.
But that doesn't mean there can't be pockets of order. Think about how life forms with their intricate structures emerge from this seemingly chaotic universe. It's a fascinating paradox.
That's really thought-provoking. It's nature is constantly balancing this drive towards disorder with the emergence of complexity and order.
And that brings us to a really fascinating concept, the principle of least action.
Okay.
This principle states that nature tends to favor the path of least resistance. So systems will naturally evolve in a way that minimizes the energy required to achieve a particular outcome.
So it's like nature is inherently efficient, always finding the most streamlined way to do things.
Exactly. Think about the path a river carves through a landscape. It'll meander and twist, but it's always following that path of least resistance, minimizing the energy needed to flow downstream.
That makes perfect sense. It makes me wonder, can we apply this principle to our own lives? Should we be striving for efficiency in everything we do?
It's certainly a valuable principle to consider.
Yeah.
By understanding the path of least resistance, we can potentially optimize our efforts and achieve our goals more effectively.
This is already blowing my mind, and we've only just scratched the surface of these fundamental laws.
So welcome back to our deep dive into these fundamental laws. You know, it's shaping our reality.
I know. It's amazing how these principles we talked about apply to everything around us.
It really is.
Last time we explored those conservation laws, the idea that energy and mass are never really lost.
Right.
Just transformed.
Yeah.
But there's so much more to unpack.
Yeah.
The book also delves into mechanics in motion.
Ah, yes. That's where we can really see these laws in action in a way that we can observe.
Yeah.
We're talking about how objects move and interact.
Right.
Things like Newton's laws of motion.
Newton's laws, those are pretty classic. I vaguely remember those from like high school physics.
Right.
Something about an apple falling on someone's head.
That's the legend. But beyond the apple anecdote, Newton's laws are so powerful. The first law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force.
So basically, things like to keep doing what they're doing,
Yes.
unless something pushes or pulls them in another direction.
Exactly.
Okay.
Inertia is the tendency of an object to resist changes in its state of motion.
Okay.
The heavier an object is, the more inertia it has, and the harder it is to get it moving or to stop it once it's in motion.
Okay, that makes sense. What about that second law?
Yeah.
That's the one with the equation,
You
right?
got it.
Off.
The second law explains how force, mass, and acceleration are related. It states that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass.
So if I apply the same force to a bowling ball and a tennis ball,
Yeah.
the tennis ball will accelerate faster
Yes,
because it has less mass.
precisely. That's why it takes more force to push a heavy shopping cart than an empty one.
Okay, starting to come back to me now. What about that third law?
Okay.
Isn't that something about equal and opposite reactions?
Yes. The third law states that for every action, there is an equal and opposite reaction. This means that forces always occur in pairs. When you jump up, you're pushing down on the ground, and the ground is pushing back up on you with an equal force.
So every interaction involves this push and pull,
Yes.
this exchange of forces.
It's a fundamental principle that governs all sorts of interactions, from collisions between billiard balls to the propulsion of a rocket into space.
Oh, wow. Okay, this is making me see like everyday actions in a whole new light. It's like
yeah.
there's this hidden dance of forces happening all around us.
Yeah.
Okay, but what about more flexible, springy interactions? The book mentions Hooke's law and elasticity.
Yes. Hooke's law describes the behavior of elastic materials like springs. It states that the force needed to extend or compress a spring by some distance is proportional to that distance.
So the harder you pull on a spring, the more it stretches.
Exactly.
Okay.
But there's a limit to how much a spring can stretch before it permanently deforms or breaks.
Right.
That's where the concept of elasticity comes in.
So some materials are more elastic than others.
Yes.
Like a rubber band is way more elastic than a piece of wood.
Precisely. Elasticity is the ability of a material to return to its original shape after being stretched or compressed.
Okay.
And it plays a crucial role in everything from shock absorbers in cars to the flexibility of our own muscles and tendons.
This is amazing. It's like these laws are the building blocks of how our world works. But things get even more complex when we start to talk about fluids, right?
The book touches on fluid dynamics, too.
Yeah, fluid dynamics is a fascinating field that explores the behavior of liquids and gases in motion.
Yeah.
It's all about understanding how fluids flow, exert pressure, and interact with their surroundings.
Okay, I'm intrigued. Tell me more about how these laws apply to something like water flowing in a river. Well, one of the key principles in fluid dynamics is Euler's law. It describes how the pressure, velocity, and density of a fluid are related as it flows through a pipe or channel. It helps us understand things like how water speeds up as it flows through a narrow section of a river.
So even something as seemingly simple as water flowing in a river is governed by these complex equations.
It is. And then we have fixed laws of diffusion, which describe how molecules move from areas of high concentration to areas of low concentration. This applies to everything from the way scents spread through the air to how nutrients diffuse through cell membranes.
Wow, so even at a microscopic level, these laws are at work dictating how things move and interact.
Exactly. It's incredible to think that these same principles that govern the movement of planets and stars also apply to the smallest particles in our bodies.
This is truly mind-expanding stuff. I'm starting to see connections everywhere. We've really journeyed deep into the heart of the universe, haven't we? With these fundamental laws.
We have.
It's like peeling back these layers of reality and finding these incredible principles at work.
It really highlights that elegance, and the interconnectedness of nature.
Yeah.
From the vastness of space down to the microscopic world of atoms, it's all governed by the same laws.
It's pretty mind-blowing. We started out talking about those conservation laws. The idea that energy and mass are never really lost just transformed.
Right.
And then we explored thermodynamics, which reveals how energy flows and transforms within systems, right?
Right.
Leading to that inevitable increase in entropy or disorder.
Yeah.
But it's not just about chaos,
Yeah.
right? We also talked about how nature seems to balance this drive towards disorder with the emergence of complexity and order. The principle of least action, that was a fascinating one. It shows us how nature strives for efficiency.
Exactly. And think back to those branching patterns we were discussing, like trees, rivers, even our own circulatory systems.
Right.
They all demonstrate this principle. They've evolved to optimize flow and minimize energy expenditure.
It's like nature is this master architect,
It is.
designing systems that are both efficient and resilient. But then we went even deeper, exploring those laws that actually govern motion itself.
Right, those Newtonian laws.
Newton's laws of motion.
Yeah.
They gave us that framework for understanding how objects move and interact, right? Revealing the interplay of forces in every single action.
Yeah, it's amazing how it all comes down to those basic laws.
Yeah. And then we got into the nitty-gritty of elasticity and fluid dynamics, Seeing how these laws play out in everything from a bouncing ball to the flow of water in a river.
It's amazing, isn't it?
It is.
How those seemingly separate concepts are actually deeply intertwined.
Yeah.
The laws of motion influence fluid dynamics, and the properties of fluids in turn affect how objects move through them.
It's all connected. It makes me wonder if we can understand these fundamental laws so well. Can we use them to our advantage? Can we design better technologies, build more sustainable cities, even solve these global challenges like climate change?
Well, I certainly think so. By understanding how these laws work, we can harness their power and design systems that are more in harmony with nature.
Right.
Imagine cities that are built with a deeper understanding of thermodynamics, maximizing energy efficiency, minimizing waste. Or transportation systems that are inspired by the principles of fluid dynamics, optimizing flow, reducing congestion.
It's like we have this incredible blueprint for innovation right in front of us.
I think so.
But it also comes with a responsibility, doesn't it?
It does.
If we can manipulate these laws, for our own benefit, we need to be mindful of those potential consequences.
Absolutely. Just like we talked about that balance between order and disorder,
Yeah.
right? We need to consider the ethical implications of our actions as well.
Right.
It's not enough to simply understand these laws. We have to use this knowledge wisely, for the benefit of both humanity and the planet.
This deep dive has been truly transformative. It's not just about learning facts. It's about gaining this whole new perspective on the world.
It is.
It makes you appreciate the incredible complexity and beauty of the universe and our place within it.
Well said. And it highlights how much we still have to learn.
Yeah.
These fundamental laws, they provide a framework for understanding, but that journey of discovery is never ending.
It's never ending, so true.
Yeah.
Well, on that note, I think it's time to wrap up this incredible deep dive into understanding nature's laws. I don't know about you, but I'm feeling inspired to look at the world with fresh eyes, to see the interconnectedness of everything
Me too.
and to ponder those mysteries that still await us.
It's been such a pleasure exploring these concepts with you.
Likewise.
And remember, the universe is a vast and wondrous place full of secrets waiting to be uncovered. So keep asking questions, keep seeking knowledge, and never stop exploring.